Hi everyone, welcome back. So if you were paying attention to the last video, we looked under the hood of my mother's 2011 Ford Taurus, and we were using that as an example of a coil on plug ignition system. So that is the more modern way to do away with a distributor. A little bit more sophisticated than waste spark, so there's some things about that we got to talk about. So when they mount the coils directly to the spark plugs, as you saw in that video, they call that coil on plug. For some types of engines, that's not practical. In particular, the GM LS series of engine that's so popular right now with the hot rod scene. Because that's an overhead valve engine, the spark plugs screw down into the cylinder heads in between exhaust ports, and that's too hot of a location to put your coil. So the engine we looked at on that Ford Taurus, the coils were right up on top of the valve covers. That's a perfectly fine place to put coils because it's kind of up and out of the way and it's not in a real hot spot in the engine. Down in between the exhaust ports by the manifold is not really a good place. So GM did not want to run a waste spark system on that LS engine. They wanted to run individual coils, but it wasn't a good way to position them right down by the exhaust, so they call it coil near plug. And they basically use 8 little individual coils mounted up on the valve cover with 8 short little spark plug wires about 5 inches long that run down to the spark plugs. So coil on plug or coil near plug, we can basically sum this up as individual coil, meaning there's a coil for every single spark plug. It's not a waste spark system. That coil only fires at the appropriate time on the compression stroke, and it's basically the ultimate ignition system. There's a couple of reasons for that. So if we think about a waste spark, I'll just show a waste spark 4-cylinder here. We have 2 coils or a coil pack divided in half. With a pair of wires going to a pair of spark plugs. If you remember, we call those companion cylinders because their pistons rise and fall together. When one is on compression, the other one's on exhaust, or vice versa. If one half of this coil pack fails, that coil dies. First of all, if it's a pack like this, you have to replace the whole thing. But second of all, 2 cylinders just went dead. 2 cylinders are no longer getting spark. That's a problem. This engine is probably not going to run on 2 cylinders. If we have individual coils, one for every single spark plug, if one coil dies, this engine's going to misfire. That cylinder's not going to produce any power, but you're still going to run on 3 cylinders. And the effect is even less on something like a V6. If you lose 1 cylinder on a V6, you're going to feel the misfire, but you're still going to be able to drive the car with plenty of power to get to a garage to get it looked at. Obviously your check engine light's going to come on, it's going to start flashing, but you're still going to be able to drive. If this was a waste spark system, you'd be losing 2 cylinders, and now you got a bigger problem. So having individual coils, first of all, is a reliability thing. It's going to be more reliable because you can really only lose 1 coil at a time, or 1 cylinder at a time, due to a coil failure. And second of all, in a waste spark system, this coil has to fire twice as often. It has to fire every single time this piston comes to top dead center. That leaves less time, in actual milliseconds, for the computer to complete the primary circuit and charge that coil up, or basically less dwell time. And on a 4-cylinder, it's not really an issue. On a 6, it's a little more of an issue because there's more cylinders to be fired. On an 8-cylinder, it's an even bigger problem. So you get more dwell time with an individual coil because all that coil has to do is fire once every time this piston comes up to compression. So lots and lots of time to build an adequate magnetic field inside there, or saturate the coil as they call it. Lots and lots of time to have basically all the dwell we need, and then less time firing means that coil probably is going to last longer. So it doesn't fire as often, it lasts longer. So there's quite a few benefits to having individual coils. So reliability, less expensive coils, but more of them. So that's not really a pro or a con. And the best, or I should say the most, available dwell time. Okay, so those are some of our advantages. So in order to use this system though, we need a slightly smarter computer, because now there are going to be more drivers or more transistors in that computer, turning more coils on and off at the right time. And the computer needs a little bit more programming because it has to be able to understand the engine's firing order. So firing order is something we have to talk about. So every engine has every multi-cylinder engine has a firing order. If you have a 4-cylinder engine, for example, it's probably going to be 1, 3, 4, 2. That's the most common firing order for an inline 4. So that as this engine's running, remember that the 2 outer pistons come up to TDC at the same time. The 2 middle pistons come up to TDC at the same time. It's going to fire 1, then 3, then 4, then 2, then 1, 3, 4, 2, 1, 3, 4, 2, in that order. So that firing order is partially determined by the crankshaft, or when the pistons are rising and falling. But remember, a piston comes up twice, once on compression, once on exhaust. What determines whether you're on compression or exhaust? What are your valves doing? So if you're on exhaust, your exhaust valve is open and you're pushing out the burnt gases. If you're on compression, both valves are closed and you're compressing the air-fuel mixture and anticipating a spark. That's determined by your camshaft. So the firing order is determined by the camshaft. And that might actually be out of frame. If it is, I apologize. Yeah, we can see it, camshaft. Okay, so I mentioned to you in the waste spark video, for a waste spark system, all you need is a crank sensor. You need a crankshaft position sensor, because all the computer needs to see is the piston coming up to TDC. If it is, we send a spark. If you have an individual coil system, so a coil on plug or a coil near plug, you need a crank sensor and a cam sensor. And based on the homework I'm getting back, I feel like there might be a little bit of confusion as to what a crank sensor actually does. So just to remind you, a CKP, which is the abbreviation for crankshaft position sensor, is there to tell the computer where the crankshaft is. It doesn't control how fast the engine goes. It doesn't prevent the engine from going too fast. That's all done by the computer and by your right foot. How far did you open the throttle? How much fuel are we injecting? Okay, the crankshaft position sensor basically just tells the PCM or the ICM in an older car where the crank is. And by that, I don't mean in the block. We know the crankshaft's in the block. I mean where in rotation is the crank, so that we can infer piston position. You'll remember that the piston and the crankshaft are connected by a connecting rod. You know, one of these things. Yes, I really do have everything in my garage. Now I have greasy fingers. Where the crank is in rotation. And basically we're looking for piston position. Piston position is good enough for a waste spark system. That's really all we need to know. We don't need to know the camshaft position because we really don't care if it's on compression or exhaust. For individual coils, I'm going to wire up 4 coils to this bad boy right here. 1, 2, 3, 4. I have to know where the cam is because I have to know, is this TDC compression or exhaust? I don't want to fire this coil twice for nothing. And I don't want to use a greasy rag on my whiteboard. crankshaft position sensor, camshaft position sensor, or what's known as a CMP, and I know I should be looking at the camera while I'm writing, but then my writing gets worse than it usually is. CMP, or camshaft, is basically the same technology as a crank sensor. It's either a magnet, a Hall effect, or an optical sensor, but it's looking at the camshaft, not the crank. This is necessary so that we can figure out the firing order and we know which coil to fire when. It's also important, even in cars that had waste spark, to know when to fire the injectors. If we have a sequential fuel injection system, if the car opens the fuel injectors in the ports exactly when the intake valve opens, it's only going to know when the intake valve opens by looking at the camshaft sensor. So that's what our CMP is doing. So we're going to have both a crank sensor and a cam sensor for an individual coil system because the PCM needs that much more information. Okay, so we'll leave the CMP there for a minute. I went digging in the basement and I pulled this out to demonstrate. This is the crankshaft pulley off of a Ford 5-liter V8, which you can see, well, you can see right here where the serpentine belt would go. In the middle you can see the hole for the crankshaft. You also notice it's rusty, it's been sitting around for a while. When you look at the back of it, I'm not sure if I'm in frame here, you see this ring of teeth. That's a reluctor for a magnetic sensor. So on the front of the engine, mounted adjacent to this ring, is this little thing here. It looks like a bat. That's my crankshaft position sensor. It's magnetic. You notice it'll actually stick to that reluctor. So it's positioned maybe 10,000ths of an inch away, something like that. Just far enough that it doesn't touch, but close enough that these teeth can disturb the magnetic field. And as you learned in a previous lesson, this thing is going to produce a little AC voltage. If you look carefully, what you might notice, lined up with this keyway on the crankshaft, the reluctor's missing, my arm's in the way, the reluctor's missing a tooth. If we count these out, there's spaces for 36 teeth, but there's only 35 teeth. It's 36 minus 1. If we had all 36 teeth there, this crankshaft position sensor would give our PCM a nice RPM signal. We would know that it's spinning. We wouldn't be able to tell one tooth from another. The wave would be uniform. So the waveform coming out of that sensor, CKP with 36 teeth, would basically look like this. Nice little AC sine wave. And I don't think I drew 36 humps there, but I think you get the idea. If we do 36 minus 1, we have 35 teeth, but they're not evenly spaced. So we don't call it a 35 tooth sensor, we call it a 36 minus 1. And when that missing tooth goes by, one little wave disappears. Okay, there's that missing tooth. That helps the PCM figure out when cylinder number 1 is coming around to top dead center. So, one more time. CKP is a crankshaft position sensor. Doesn't have to be magnetic, doesn't have to be producing an analog signal. Could be a Hall effect or an optical sensor. But it is going to provide our RPM signal to the computer, so the computer knows how fast we're going. But more importantly, it's going to provide a position reference to the computer, so we know when cylinder number 1 is coming up to TDC. The cam sensor is going to do the same thing, but it's going to tell our computer whether we're coming up on TDC compression or TDC exhaust. So we need both of these sensors to be working for an individual plug or individual coil ignition system to operate properly. And by the way, if you haven't guessed already, the reason they chose 36 teeth is 360 degrees in a circle, so it just kind of made sense. 36 teeth. Each tooth or each wave means 10 degrees of crankshaft rotation or revolution. So some manufacturers use 60 teeth. I've seen 24 teeth used on crank sensors. It's really up to the manufacturer, however they choose to do it, how accurately they want to measure the RPM. So it's really up to them. They could do it with 4 teeth. It just wouldn't be very accurate. They'd only know every 90 degrees of rotation. So That's our Ford 36-1 position sensor. So I'm going to erase this for a moment. Okay, so here's my quick and ugly engine. There's my oil pan. Here's the valve cover, cylinder head, crankshaft pulley. Okay, so we're going to mount some coils up here. 1, 2, 3, 4. We're going to wire those up to the PCM. Somewhere down here, down by the crankshaft, we're going to mount our CKP. And then if it's an overhead cam engine, and this day and age it's going to be an overhead cam engine, somewhere up by the camshafts, probably on the cylinder head, we're going to have our CMP. So PCM's got some programming in it. It knows what the firing order of the engine is. It knows how the engineers designed the camshaft. It's programmed to know it's a 4-cylinder, so there's 4 coils. So there'll be 4 individual transistors, 1 to trigger each coil. It's got a CKP to tell us where the crankshaft is, and it's got a CMP to tell us where the camshaft is. So if it knows that this 4-cylinder fires 1, 3, 4, 2, when these 2 sensors work together and tell the computer cylinder number 1's coming up to TDC on compression, we're going to fire that coil. Then in 180 degrees, we're going to fire this coil. And in 180 degrees, we're going to fire that one. Then in 180 degrees, we're going to fire this one. And then back to number 1. And we're going to just keep repeating that cycle. So that firing order is kind of important. I think this is the clean one. So every engine has a firing order. Like I said, 1, 3, 4, 2 is pretty common for 4 cylinders, except Subarus. As you remember, Subarus are boxer engines. They have a different firing order. Off the top of my head, I don't know what it is, even though I drive one. It's Coil On Plug, and it's buried down on the side of the engine. You can't really see it very well. That's why we didn't take a video of my car. But basically, you can't mess up the firing order on a Coil On Plug Ignition. When we have waste spark and coil packs, you can definitely mess up the firing order. If I go to replace these spark plug wires, if I put them on in the wrong positions, the spark is going to be going to the wrong cylinder. So even though the computer still knows what the firing order is, that spark can't get to the right place at the right time, it's going to misfire. Probably not even run. The same thing used to happen with our old distributors. If you put the spark plug wires back on the distributor cap in the wrong order, it would either misfire or not run at all. So that was a common backyard mistake. Somebody in the olden days thought they were swift enough to do a tune-up on their own. They'd whip off all the spark plug wires without making a diagram, not knowing the firing order, and then they'd just put them back on where they thought they went, and the car wouldn't run. So this about does it for an overview of how an individual coil or a coil on plug ignition would operate. There's one more thing I'd like to mention about firing orders. No matter what your firing order is, let's say it's 1, 3, 4, 2. Or let's say it's a V6. A lot of V6s fire 1, 2, 3, 4, 5, 6. Or maybe it's a Chevy V8. 1, 8, 4, 3, 6, 5, 7, 2. Yes, I know it's a waste of brain space to memorize that, but when you tune up enough of these things, you just learn it and you never really forget it, kind of like a phone number. So that number is tattooed in my brain for all of eternity now. If you divide this in half, or right here, 1, 2, 3, right here, 1843, you can find your companion cylinders. So if you were ever not sure where the spark plug wires went on these coil towers, or if you ever noticed that every time I draw the Chrysler ignition with the inline 4 and the coil pack here, these two go to cylinders 2 and 3, these two go to 1 and 4, you can figure out that they're companions. 1 and 4 are companions, 3 and 2 are companions. On the V6, 1 and 4 are companions, 2 and 5 are companions, 3 and 6 are companions. Those pistons are rising and falling together. On the Chevy V8, 1 and 6 are your companion cylinders, 8 and 5 are companions, 4 and 7 are companions, 3 and 2 are companions. So that's a little trick you can do with a firing motor. That's kind of good to know. And that's basically all I really wanted to talk to you about firing motor. The reason that they come up with these firing motors, by the way, is for balance. So if you took a V8 engine, and we'll label it like a Chevy, 1, 3, 5, 7, 2, 4, 6, 8. If you just made these cylinders fire 1, 2, 3, 4, 5, 6, 7, 8, this engine would physically shake on its engine mounts. It wouldn't run smoothly. It would subject the crankshaft to unusual twisting forces and torsional loads, and it would basically decrease the strength of the engine. The engineers figure out how to pick a good firing order so that the stresses are minimized in the engine and the power is produced in the most in the smoothest way possible and with the least amount of vibration or shaking of the engine. So that's something that the engineers deal with. We don't really have to worry about this so much, but we do have to follow it when we reconnect the spark plug wires, if we have spark plug wires, if that makes any sense. So just something you should be aware of. So firing order is kind of important. Basically, it's just determined by the mechanical design of the engine, and then the computer is programmed to know what it is. And we just have to observe it properly when we're hooking everything back up. So I hope this clears up any questions you might have had about crank sensors and cam sensors. And I hope it gives you a pretty good overview of a coil on plug system, why it's the ultimate ignition system and why pretty much everything nowadays uses it. All right, till next time.